Okay, so I'm live with Assimilating Python for Rust, right? So the idea here is that I'm going to be shifting from only covering Python. I had a whole series where I was talking about Python and how do I shift towards maybe incrementally building solutions with Python and Rust. I think there's a lot of interest, I think, in Rust for good reason. One of the reasons why people are interested in Rust is the performance is just incredible, right? In terms of energy and energy efficiency as well. Rust is one of the most energy efficient languages, and also the packaging, right? Packaging is one of the strengths of Rust, where packaging is a weakness for Python. So let's go ahead and dive into this and go from there. So what I'm going to do is I'm going to share my screen and I'm going to present. Let's go ahead and get this cooking. So the idea would be that I'm going to go to a new repo, I think would be the way to do this. So let's go ahead and do that. And I'm going to show you actually one of the techniques of why this is kind of cool. So I'm going to say new repo, and then I'm going to say from a template. And what I'm going to do is I have already a Rust a new project template. And so I'm going to go ahead and select that. And then what I'm going to do is I'm going to say assimilate Python for Rust. There we go. Perfect. And so this repo will be, this repository will show how to use Python with Rust. So I only conceptually know about this. I don't in theory know about, I don't in practice know about Python with Rust. I've done a lot of Rust, but I haven't done enough yet with Python. I'm going to go ahead and dive into this and we'll see what happens. A couple things that I typically like to do when I first set up a new repo inside of GitHub is that I do like to do the code space pre-build. I think it's a really good idea to just, bake everything out so that it's really fast when you launch. You just go to main, every push, and then say create. So this means that behind the scenes, anytime I make a change to this repo, it'll just go ahead and push it out. So the next thing I'm going to do is just take a look real quick at the structure, right? We have dev container here, Docker file, JSON file. If we look at the Docker file here, you can see that I have Rust, the default dev container here for Rust that I'm going to use from Microsoft. And then in terms of the config here, it's going to really not do much tricky other than I'm having GitHub Copilot, which I think is really helpful. And then I have a setup command. And let's look at the setup. What does that do? I don't know if I do have a setup here. So if I need it, I can do a setup that will, I don't know, install Python or something like that. But I think this is good enough to start with for me to play around with it. So I'm going to go to code. I'm going to go here and I'm going to say new with options. And what I can do is do 16 core right here. There we go, 16 core, 32 gigs of RAM, 128 gigs of storage, and perfect. We got this thing set up. All right. And this will take a little bit of time to build the container. And again, that's why I like the dev container pre-builds, so that this thing is already done for me. In the future, it would be awesome if GitHub had a bunch of different options that were pre-built and you could just pick it and it immediately would launch and you wouldn't need to do much. So while this is spinning up, I'm going to get the repo, the resources that I'm going to use teed up. And so what I can do is go through and look at the Rust Python bindings. So this is interesting. Rust Python. So, wow, that's kind of cool. I mean, maybe I'll just try all kinds of things here. Well, embedding Rust Python in your Rust application. Wow, this is kind of a cool concept. What is this thing? So we got Rust Python, a Python interpreter written in Rust. Whoa, that's kind of cool. Man, I'm glad I discovered this. So we'll take a look at that. And then I'm also going to look at the bindings. I think it's called PyO3 uh, here as well. So Rust bindings for the Python interpreter. So we'll take a look at a couple different approaches here to get it going. If again, as this thing is kind of spinning up, it gave me a chance to pull up some resources. So the first thing is, do I even have Python running? Right. That's probably the first thing. So Python. Okay, we have Python 3.9. That looks good enough. And probably for people that are new to Rust, what I should do is just first show what Rust can do, and then I'll get into the Rust plus Python. So, why do I care about Rust? Why is it such a good thing to learn? I think part of it's just the performance is just so killer in terms of Rust, and so we can say Rust, assimilate Rust in Python. Rust. So the first thing we'll call this day one is to set up a REST and Python interaction. Okay, so what do we do? Let's first demo what Rust can do. And I think I will be able to do this really quickly. Let's double check. Is this activate? Yeah, I want Copilot on. And let's go ahead and say cargo new. And what I can do is just create a new project here. And we can just call this, hello. We go. And so what happens when you use cargo, unlike Python, where there's kind of some hoops and you jump around to do different things, from the very beginning, packaging is a first-class citizen for Rust. And so if we go through here, and I'll put the notes here of what it is that I ran. I'll say cargo new hello, like that. And then if I cd into that, and take a look at the infrastructure of what's involved with Rust. So first up, we have cargo, right? And so in terms of cargo, we have a name hello. We also have a main right here, which is good, hello world. And this is the way that I would first start building things. Is I would actually basically run this using the cargo tool. And so what I typically like to do is actually have a like a makefile basically do a lot of the work for me. And so what I can do here is actually take a look at some of these things here. So we could do Rust version. So if I type in make Rust version, well, actually let's cp this makefile into this directory right here. Now I can type in that stuff. I can say make Rust version. And it's just going to show me like what version of Rust I have, the tool chain, all that kind of stuff. The next thing is that this format is just critical to be able to format your code. And it's awesome because, again, Python you have to actually install this stuff. You have to do like, pip install Python Black. You have to pip install PyLint, all this. But with Rust, cargo is essentially a tool that just provides all of this from the beginning, which I think is great because it gives you like a streamlined path to actually build out what it is you need to build out. And so if I go ahead and I say make format, it's just going to use the default tools that are inside. And it's just lightning fast, right? Because it's a compiled language. Same as if I do make lint, it goes through, there's a built-in linter. The linter is amazing. If I wanted to write unit tests, I could just say make test. If I want to build the project, it's trivial, right? I just say make run, which is cargo run. There we go. It compiles it. It prints out the hello world. So it really is, in my opinion, like long-term, probably easier to be a Rust programmer than it is to do Python. I think a lot of people are intimidated maybe a little bit by the syntax, but I think everybody is able to actually be a Rust programmer. So what I'm going to do here is just start and build something a little better than just a hello world here to show why it's so important. Now we know in Python, right, it's just a function. It looks similar in Rust as it does to Python, but let's make something a little bit bigger, which is let's build out a library and then we'll invoke that library from a command line tool. I think that's one of the better ways to learn a language. So what I'm going to do is I'm going to make one more file here. So I'm going to create a source lib.rs right here. And in this lib, I want to build out something that will be kind of a fun tool to play around with. Now, one of the ways that you can get up to speed very quickly with Rust is to leverage GitHub Copilot. So in order to do that, we'll go ahead and we'll do a comment here that I always screw up the Rust comments. Why is it that there you go. So we'll say a library for doing Marco Polo. So like really a silly thing here, but check this out. So Copilot is so smart, it gives me an idea of what I might want to build quickly. A couple things to point out here is that notice what it gives me. Let's just even let it complete. So it gives you the function syntax, which is fn, and then the name of the function. So this is pretty intuitive, and it just says here that the function returns a string, and then this exposes this so that if I want to use it inside of my command line tool or my main function later, that's it, right? So it's actually pretty straightforward. I want to tweak it a little bit here, though. I don't want this. And so that's one thing to be aware of when you're building the correct prompt for Copilot. There's some skill involved, right? So you need to actually be able to go back and forth and interrogate the prompts, right? This is called prompt engineering. So what I'm going to do is I'm going to say build a Marco Polo function that returns Polo if you pass in Marco, right? So I want it to take an input, otherwise returns no. Not Marco. There we go. That looks good, right? So you do have to kind of, tell it the right thing. And then once I do this, look, now we got something a little bit better, and we can use our Python intuition to actually get better at Rust, right? And so it's not like you just lose all the Python programming skills because you started programming in Rust. You just use the same kind of style, but you put that skill into Copilot, right? Now, let's again look at this. So this says expose this function to main, right? Which is what we want. And then we build a function here. So look, it's not that much different from Python. Only thing we have to do is we have an input, which is the variable to the function, and then we have to declare a type. Now, the reason why typing is not that big of a deal is Python itself now has optional typing. Two, Copilot and the editor inside of Visual Studio just puts the types in for you. So why do you care about types? I don't think most people should care about types. And then the other thing to consider is that the string, right? The string is going to be returned. So you just have the input right here, which is a string, and also the output, which is a string. And then we look at the logic. It's pretty intuitive, right? You say if the string that's passed in is equal to Marco, then you're going to return Polo to string. Otherwise, you're going to return back the opposite, right? And if we go through here, the next thing I'll suggest is every time you get what you think is correct answer, then what I would recommend, and I'll even put a note here, is like the formula for using GitHub Copilot is as follows. Copilot. One, write comment that describes what I do with a function. Two, format the code. Format code with cargo. And so this is critical because it's going to actually help out your suggestion. Like it's a feedback loop. You're telling the Copilot system to actually get a slightly better answer because of it. And then three, what you want to do is you want to run lint. You want to say lint your code. You just do these three things. Basically, you can very, very quickly convert from Python to Rust. That's it. This is a secret that not many people know, and I'm telling people about it. So let's do it. So what do? We just say make format, right? Which is similar to what I would do in Python, and it cleans it up. So we look like pro programmers. The next thing we do is we say make lint. Now linter is so amazing in Rust that it basically writes our code for us, but it's not even an AI tool. It's just a linter. So as long as it passes formatting and linting in Rust, you're very, very good chance you're good to go, which is, I think, an amazing capability of the Rust language. Now, we got something that I think will work. Now, this is the part that may trip up people in Python. I was like, okay, well, how do I run this? Like, blah, 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 blah. Well, here's what we need to do. We need to actually use a command line tool to do a lot of the work for us. So what I'm going to do here is I'm going to go to cargo.toml and I'm going to go to Rust collab. I'm going to look at an existing repo that I built out that has a bunch of demos in it. And I'm just going to steal some code. So this is always, I think, a good idea is just take something you've already built. So here we go. Here's my dependency. Let's throw that in. Now, the way this works is that, again, unlike Python, which has like an infinite amount of ways to install packages, Cargo has one. And you put it into the cargo.toml. And this extension that comes with Visual Studio, it automatically tells you what versions are available, right? So it's amazing functionality. The next thing we have to do is put a little bit of boilerplate code, not much, inside of the main. And this also is what I typically do is I'll just like copy like something from another command line tool, and I'll just go back here and I'll go to the main and I'll just go like that. Now, we do want to tweak this so that the AI tool, Copilot, is in sync, right? So we'll say command line interface for, let's change it, Marco Polo. And we can say command line interface for Marco Polo. Right. Now it's going to kind of know how to put everything together, right? We're giving it the right prompts. And then for this, we also can now tweak it. We want to map it to a subcommand, and we can just call this, I don't know, Marco. Let's say Marco, and then look what it's going to do. It's going to you only need to run. I don't want to do that. I want to do. I gotta find my prompt here a little bit better. Let's try that. Actually, I can even find one from a project that takes a string. I think I even have a Marco Polo inside of here. There we go, Marco Polo. What does this one do? Main. There we go. Yeah, this looks good. I like this. So let's why reinvent the wheel? Let's just be lazy. There we go. Now I'm going to change this though to Marco. Like Marco. Or let's try let's do Marco. Let's do Marco. So basically what's going to happen is that it's going to accept a name, which is a string here. And the next thing that I would need to do is pull it all together. Now, again, Copilot is our friend. It's pretty smart. And it says it's able to actually pull this together. Now, one thing that we're going to have to do, which I've noticed that for whatever reason, Copilot is a little bit like out of sync with, is that, and this will trip up somebody that's new to Rust, is that this namespace is critical in order for you to invoke the library function, right? So it's a little bit magical, but whatever the name is of your package, you have to use that namespace to invoke what's inside of the library. So what we have to do is, notice here it says, hey, I'm gonna invoke that code. So what we need to do is we need to say hello, double dots like this, Marco Polo, like that, right? So what's going to happen is that basically we're going to actually get the result of that. So we'll even say let results do that, and then in terms of instead of here, we'll call this input, and then we'll also say input right there. I think that should work. Marco Polo input here, and now this is where I would do a format. So I would say make format, and so I screwed up something here. Let's see what I screwed up. That would be results. is it a semicolon or I think you have to do a semicolon after a statement here. Let's see here. Apollo. Let's try that. There we go. So you have to kind of riff off this a little bit and then print the result. There we go. So there's a feedback loop of like, hey, am I getting things right? And then I format and I kind of go back and forth, let the co-pilot kind of help me out and figure things out. It's again like you're pair programming with somebody. And then I say make format again. Happens. Okay, we're good. We're formatting. Now, I don't know what this is, but sure. And let's do make format. I don't know what this we can I don't want that actually. That's good enough. But we can say basically if I pass in the Marco command to the command line, we're able to actually run this. And now here's the magic is now I lint, right? So I just say make lint. Let's go. Boom. If it passes lint, you're good. And that's what gives me so much confidence about using Rust is that, boy, once you understand that it passes lint and you're good to go. So basically you cd into hello, and then you just do this. You just type in cargo run, you dash dash like that, and then you do dash dash help. And this is how I would recommend people build, solutions. Is always build a command line tool at first. How do we do this? Easy. We just type this in. Again, let's look at the main function and let's see what happens. So what's going to do is now we get to leverage the compiler. I mean, it's not often, but sometimes it won't compile. But almost always, if you use lint, it'll probably compile. In this case, it did. It worked fine. Look, it tells us it's a lot like Python command line tools. Oh, look, Marco. Okay, cool. Let's do this. Let's go ahead and go through here, and let's just type in Marco. And we can also do help if we want. It goes, hey, what is it? What does it want us to do? It says, oh, input. So it wants us to do input. Okay, great. Let's go ahead and do that. Let's say input, and we'll just say Marco. What does it return back? Polo, right? And if I put in, Bob or something like that, what happens? Marco, right? So I think a lot of people have told me like, oh, Rust is so hard. You can't do it. Oh, it's impossible to learn Rust. Oh, la, la. No, it's not too hard to learn Rust. Anybody that's a Python programmer can learn Rust. I just demonstrated how easy it is to actually learn Rust. In fact, you can just literally recreate exactly what I did by watching this. And in fact, here we go, results, right? Which is this, right? So my opinion is that Copilot is a revolutionary new technology, and hopefully I'm demonstrating it, why it's such a big deal, because it allows you to leverage very powerful tool chains and actually have a feedback loop, right? Because I can leverage all of the cargo ecosystem with the Copilot prompts and go back and forth on, I've actually got a significant advantage over people that don't use a compiled language and that don't use Copilot. I'm going to run circles around them because now I can code in a language that's 25 times faster. So I think this is very, very, very important for people to be aware of. And so I'm going to go ahead and check all this in. So let's say get status here, and let's go up a little bit and say get status, get add hello, and there we go. Oh, that's a bad sign. hopefully I didn't check in a bunch of binary files. Let's look at the get ignore. Well, I might have, but we'll see. Adding projects. No. So I need to have a better get ignore file here, which I probably can look at my get ignore here. So I screwed one thing up, which is I checked in a bunch of binary stuff, which sucks. But it is what it is. So here we go. Let's go ahead and tweak this. Say get status, get add, get ignore. So in the future, I won't have to deal with this. Right, so that's always one of my Achilles heels is I check in the wrong things. Adding better get ignore. That should in the future prevent me from having problems. There's all these tricks to delete binaries, all this stuff, but oh well. I made this a kind of a big repo. I'll fix it later and get rid of all the weird stuff that I checked in here. But the other thing I'll point out is in the README, we're going to call this day 1. So for day 2, I think the best thing to do would be to is look at the setup for Python and Rust. And so I'll check out this, which is the PyO3, and I'm also going to check out this a Python interpreter written in Rust. So there's some very, very exciting things here for people to play around with. The last thing that I'll leave at, and this is one of the reasons that I think Rust is a significant advantage over Python, is let's check this out, this target directory, right? So from the beginning, it's like a production first mindset. So what it means is that if I ls hello, and then I ls target, and then I ls debug, and then I ls the hello, it builds a binary for me from the very beginning. So I have a deployable binary, and I didn't have to do anything, right? So if I wanted to build a GitHub package out of this, I just put it up to GitHub package, and it's automatically ready. And that's why when I later get into doing things with like AWS Lambda and Rust, you'll see like it's trivial to do deployments. It's dramatically simplifies things. So if we go through here and I go and I run this, let's try that. Right. So what's amazing, look at this. I already have a built binary here that is good to go. So this is what's in my opinion the killer also feature of Rust is it's production first, right? As soon as you work on the project, the deploy is solved, right? There is no like extra thing you do. It by definition, if you use Rust, you're building deployable tools, and that is not the case, in fact, with Python. All right, so this is a good thing to kind of leave on here, make it a little bit bigger for people, and we'll go ahead and leave it there. I'll be back for this particular series in a couple weeks, but I think I gave everybody some good stuff to play around with. Obviously, I would maybe rerun it if you want to check it out. But in a nutshell, just on closing here, deploy. My main takeaway would be that I've heard many people say this, like, oh, Python people can't learn Rust. False. Python people can learn Rust. Is trivial to do Rust. And in fact, you have massive advantages because you don't have to do things with the Python packaging ecosystem, and you don't have to deal with the GIL. You don't have to deal with some of the limitations of Python. And I would definitely encourage anybody that's a Python programmer, hey, try it out. I just showed you a really quick demo of how to do it. And I personally think Rust is an amazing language to do MLOps with. All right, that's it for me for today.